All right, this is Algebra 2 Spring Test number 11 study guide. First question asks you to find the measure of the angle below. It's a little ambiguous as to which angle. It gives you this measurement is 60 degrees here. So what it's asking you for is the entire measurement from there to here. You know that if it opens up all the way straight up, it's 90. So you're going to add 90 to 60. That's 150 degrees for that one. Then it says sketch the angle in standard position. Remember, standard position starts at on the x-axis there, and it opens up if it's positive, and it opens down if it's negative, or it goes counterclockwise positive and clockwise negative. So 255 degrees, you're just sketching it. You don't have to be perfect. You know this is 90. You know this is 180. And you know this is 270 degrees, and this, when you get all the way around, it becomes 360. So we know we have to go less than 270. So we know if it opens up this direction, it'll open up till about right here. That's an angle that's approximately 255 degrees. The other one says negative 95 degrees. Remember, if it's negative, it's going to open up going down or going clockwise. So again, it starts in standard position, but it's going to open up this direction. You know this is 90 here, and this is 180, or it's negative 90 and negative 180 respectively. You know we're going to go past 95 degrees. So just go just past 90. Again, it's just a sketch. It doesn't have to be perfect, but that's negative 95 degrees. Number 4 asks find the measurement, or tells you to find the measurement of an angle between 0 and 360 degrees, coterminal with an angle of 86 degrees in standard position. So only one revolution, so you're not going all the way around. You're only going all the way around one time, but you want the one that's coterminal. So if you're looking at this from what's going on, 86 degrees is the measurement that if it goes, it's not 86, but negative 86, it's going to open up down, and it's not going to quite get to negative 90. So the one that they tell you is negative 86. It looks like this. It's asking you for the coterminal one. So you want a coterminal one. That just means the other one that ends on this at this same spot. So if it opens up this direction, what's that angle going to be? Well, we know it's going to be positive, and we know all the way around is 360 degrees. So simply take 360 and subtract 86 from it in order to get your coterminal angle. You got to borrow one. 10 minus 6, you know, is 4. Since we borrowed one and we borrow again, we got 15 minus 8, which is 7, and then 2 is by itself. So 274 degrees is the coterminal angle. Number 5 says, in which quadrant does the terminal side of negative 144 lie? So again, it starts here. Negative means it opens going down or clockwise. You know this is negative 180, so we're not going to go that far. This is negative 90, so it's going to be somewheres here. It's negative 144, so that's quadrant 1 here, 2. This is quadrant 3 is where it ends. Find the value of x, round your answer to the nearest tenth. This is geometry right here. So this is your reference angle. We're starting to understand what reference angles are now a little bit more based on the context we've been using this last week. In reference of 20 degrees, x is the opposite, and 8 is the adjacent. You don't have a hypotenuse. So SOHCAHTOA tells you how to solve it. SOHCAHTOA, or sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. The only one that uses an opposite and an adjacent is tangent. So you set this up as the tangent of 20 degrees is equal to the opposite, which is x, over the adjacent, which is 8. So in order to get x by itself, you multiply both sides by 8, not by x, by 8. And when you multiply the right by 8, you have to do the left. This one cancels out and gives you what x is. So x is going to be 8 times the tangent of 20. So 8 tan 20 is all you're doing. And you get 2.9. Yeah, 2.91. It says rounded to the nearest tenth. So 2.91, it keeps going. So we'll say that's approximately, x's side is approximately 2.9, rounded to the nearest tenth. Number 7, we're doing the same thing. You have an opposite, again, in reference of 60, and an adjacent in reference of x. We don't have a hypotenuse. That's the same formula we used for number 6. So we're going to say the tangent of 60 now equals the opposite 6 over the adjacent x. Now this becomes a two-step problem because you have to move x and then you have to move something else away from x. So this says divide by x. In order to cancel out divide by x, multiply by it. If you multiply that side, you multiply this side. Now you got something that says x times the tangent of 60 equals 6. We don't want that. We want x by itself. So get rid of the fact that it says times the tangent of 60 by dividing by the tangent of 60. If you do it there, do it on this side. So 6 divided by the tangent of 60 is going to give you what x is. So punch in 6 divided by, and then you might have to open up a set of parentheses on your calculator. Tangent of 60, then make sure to close both sets of parentheses, and you're going to get x's value is equal to 3.464. It keeps going. Again, we're rounding to the nearest tenth. So we need to determine by using 6 if we got to go up or not. That's 5 or greater. So x is going to be approximately 3.5. Number 8, again, find the value of x. But this time, in reference of this angle here, we have an adjacent x and we have a hypotenuse 9. So SOHCAHTOA, C-A-H, the cosine one uses an adjacent and a hypotenuse. So the cosine of 36 degrees equals the adjacent x over the hypotenuse 9. So this is just a one-stepper since the x is on top. Get rid of divided by 9 by multiplying by it. Multiply both sides. So 9 times the cosine of 36 is going to give you approximation 7.281. So x is 7.281. Again, we're rounding to the nearest tenth. So we'll call x equal or approximately 7.3 to the nearest tenth. Number 9, write this expression as a simple logarithm. Remember, the first thing you do is move the coefficient to an exponent's position. So log base b of w is now raised to the 4th power, plus this one, move it to the exponent position, log base b of t to the 6th power. Both of them say log base b, and they're adding, so we can combine both of those to log base b of w to the 4th times t to the 6th. And this is written as a single logarithm. For number 10, you're expanding the logarithm expression. It's division. Remember, addition pairs with multiplication. Division pairs with division does pair with subtraction, though. Both of them are going to have the base log base 4. So we'll say log base 4 of n minus log base 4 of 12. That's all you can do with that one. Number 11, add if possible. We can do it because they're both the 4th. Notice their index is the 4th root. The 4th root of 10x for both of them. So all you do is add the coefficients, 6 and 2. And you get 8 times the square root of 10x. Number 12, simplify these. Remember, the bottom number is the index. So if you're looking at them as radical form, it'll be the square root of 2. The top number, this one, is what you raise it to the first power. So the square root of 2 is going to be the square root of 2, and it's raised to the first power. So that one will simplify to the square root of 2. The same thing with the other one. It's the same thing. So it's the square root of 2 raised to the first power. So it's the square root of 2 times the square root of 2. And the same radical times itself is simply whatever that radicand is, 2. If you multiply them by each other, you get the square root of 4, which we know the square root of 4 is 2. This one says 8 to the 2/3 power. Again, the bottom number is the index. So that's saying the cube root of 8. The top number is what you raise it to after you take the root. So the cube root of 8, 2 times 2 times 2 is 8. So the cube root is 2, and 2 squared is 4. 14 says to write it in radical form. 2 times, notice this is the part that's being raised to the 2/3 power. So it's 2 times x, or the cube root, again, because that bottom number is the index, the cube root of x. The top number, the numerator, is what you raise it to, squared. So this is it written in radical form. 2 times the cube root of x squared. 15 says write this one in simplest form. Everything is getting raised to the negative 4/3 power. So 8 is getting raised to the negative 4/3 power, and a to the negative third is getting raised to the negative 4/3 power. Remember, anytime you raise a power to a power, you multiply. So if we multiply straight across, we'll put this over 1. Negative times a negative, 3 times 4 is a to the 12th, over 1 times 3 is 3. So that gives you a to the 4th power when you divide 12 by 3. 8, on the other hand, is being raised to the negative 4/3 power. Remember, just like on numbers on 14, 3, the bottom number, is the index. So what it's saying is the cube root of 8, I apologize, even before you separate it, you go with the fact that it says, or you take care of the fact that it says negative 4/3. Remember, negative 4/3 means it has to ride the elevator. So it goes down and becomes 1 over 8 to the 4/3. Now it's positive. Again, 8 to the 4/3 power. The 3 is the index. So it's saying the third root, or the cube root of 8. The 4, the numerator, is what you do with it after you take the root of it. So the third root of 8, 2 times 2 times 2 is 8. So the cube root of 8 is 2. And 2 to the 4th power means 2 times 2, which is 4, times 2 is 8, times 2 one more time is 16. So what this simplifies to here is 1 over 16 times a to the 4th. And when we put those together, we're left with a to the 4th over 16. And that's the simplified version. Number 16 says multiply or divide, then state any restrictions on the variable. W plus 4 over W minus 2 divided by W plus 2 over W squared minus 5W plus 6. First things first, division of fractions means to multiply by the reciprocal. So we'll flip all of that. So the first one's going to stay the same, W plus 4 over W minus 2. The second fraction, it becomes multiplication. And the top, W plus 2, goes to the bottom. We have to factor the trinomial. So in order to factor W squared minus 5W plus 6, we'll multiply W times W to get W squared. Then we're going to take our factors of C, 6, 1 and 6, and 2 and 3. Which pair gets you to B? 5. Both of them actually do. So we have to choose based on the signs. Remember, the plus here tells you that the signs are going to have to be the same sign. The minus here tells you the larger one has to be minus. So the only way that we can have them be the same sign in the larger one, since they're the same sign, actually, I misspoke. Since they're the same sign, they both have to be minus. We have to use the numbers 2 and 3. and they both have to be, since it says minus, they both have to be -2 and -3. Remember, whatever's exactly the same at the top and the bottom, you cancel it out. W minus 2 is the same as W minus 2. So you're left with W plus 4 times W minus 3 over W plus 2. And here is your simplified version. Where it says state any restrictions on a variable, remember the bottom number cannot be 0. So the only number that you can combine with 2 that gives you the number 0 is -2. So W cannot be -2. That's the restriction. Every other number will work fine, or every other number that actually solves for it when you get something more that you can use. 17 tells you to factor this one. Again, you're making two binomials. X times x gives you x squared. Your factors of 70 are going to be 1 and 70, 2 and 35. 3 does not go into 70. 4 does not go into 70. 5 does. It goes into 70 14 times. 6 does not go into 70. Neither does 8, but 7 does. 7 times 10. And they were close. The only thing is, I jumped from 6 to 8. I'm not sure why. But neither does 9. So those are your factors of 70. The only pair that gets you to B's value, the only pair that gets you to 17 out of that whole group is 7 and 10. None of the other pairs even work. So 7 and 10 is what you have to use. This sign says they both are the same. This one tells you they're both positive. So plus 7 plus 10. Number 18 says solve this one, check your solution. Remember, you undo order of operations backwards. Please excuse my dear Aunt Sally becomes Aunt Sally, my dear, excuse please. So you look for anything that says addition and subtraction first. You have -9, you add 9. If you do it there, do it here. -8 plus 9 is 1 equals the square root of Q. In order to cancel out, now the only other thing that's keeping Q from being by itself is this square root, this radical sign. Undo that by squaring that. And if you square the right side, square the left side. 1 squared is still going to be 1. So Q's value is 1. Undo before you undo the exponent. Because remember, you work backwards when you undo. Before you undo the exponent, you undo multiplication and division. There's no addition and subtraction to take care of. So get rid of 6 times x squared by dividing by 6. You do it there, do it here. X squared equals 10. Undo squaring something by taking a square root. If you do it there, do it here. X is going to be by itself equals the square root of 10. And remember, that'll be both a positive and a negative value, since that doesn't simplify any further than the square root of 10. 20 says solve the quadratic by completing the square. This is not a perfect trinomial. We can't factor this one out and get the number 4, because 6 and 1 and 2 and 3 don't give you 4. So what your first thing you need to do is move the C value that doesn't work over to the other side. In order to do that, you add 6 to both sides. If you add it here, add it on the right. Now you have x squared plus 4x plus C equals 6. We need to find a new value for C. In order to find C, remember, you take B, you divide it by 2, and you square it. B's value is 4, so 4 divided by 2 squared is 2 squared, which is positive 4. So the new value for C is 4, but you can't just add it there. You have to add it to both sides. 6 plus 4 is 10 on that side. Now what you want to do is take that perfect trinomial and take the square root of the first term. The square root of x squared is x. And take the square root of the C term. The square root of 4 is 2. The sign before B plus tells you what goes in between them. So x plus 2 in that whole binomial is squared. We are almost finished. X plus 2 squared equals 10. In order to get x by itself, cancel out squaring something by taking the square root of that side. If you do it there, do it here. It will cancel out and leave you simply with x plus 2 equals the square root of 10. And then get rid of plus 2 by subtracting 2 on both sides. This does not give you the square root of 8. Remember, those are not like terms. So x is equal to negative 2, both plus and minus, whatever the square root of 10 is. #21 says find the cosine and sine of 150. Now what you're going to want to use is that unit circle now. The cosine is of 150. So look at this point here. If you look over at it, the cosine or that point is, I'm sorry, that point over there is the negative square root of 3 over 2 and 1 over 2. So that's what that point is. Those are its values. Now, if you look at this reference angle here, which is what we introduced this week, the reference angle, your y value is 1/2. Your x value is negative square root of 3 over 2. So if you're looking only at this reference angle here, the sine is the opposite over the hypotenuse, and the hypotenuse is always 1 in this case. The unit circle talks about radius or the radii being 1. So it's the sine, or if we do cosine first, since that's what it asked for first, the cosine, ca, C-A-H, catoa, the so catoa part. The cosine of 150 degrees equals 1/2, or the y value, the opposite, this one here, 1/2 over the hypotenuse 1. So the cosine of 150 is 1/2. I'm sorry, that was the sine I was doing. So all we got to do is change this one to the sine. That'll be the sine one. The SOHCAHTOA part, so, because that was the opposite. So the sine of 150 equals 1/2. The adjacent one is this one here. So the cosine of 150 equals negative square root of 3 over 2. And that would be over the hypotenuse, so it'd be over 1. So this is the cosine of 150 degrees, and this is the sine of 150 degrees. The exact value of the cosine and sine of 300 degrees. So again, look at your unit circle. As you look at your unit circle, this is, remember, this is 90, this is 180, this is 270, and when you get all the way around, not only is it 0, it becomes 360, and every time you use a revolution, you add another 360. But it's saying the cosine of 300. If you look 30 degrees past 270, that's going to be 300 degrees. So all the way around to that point. Now, if you look at those values on your unit circle, that point is at 1 over 2 negative square root of 3 over 2. That's your x and y value. So it's asking you for the exact value of cosine 300 and sine 300. Again, if you think of that in terms of the reference angle, you can determine which value is which. Your y value is negative square root of 3 over 2, and your x value, this one here, is 1 over 2, or 1/2. So that reference angle, this one, is talking about the cosine of 300. That's the adjacent over the hypotenuse. Remember, the hypotenuse is 1, talking about radius 1. So the cosine of 300 degrees equals the adjacent 1/2 over 1. So here's your cosine of 300 degrees. Your sine, on the other hand, is the one that is the opposite. Remember, SOHCAHTOA, that's the opposite over the hypotenuse. So your sine of 300 degrees is the opposite, negative square root of 3 over 2, and it would be over the hypotenuse over 1. So here is the sine of 300 degrees. Again, look at all those numbers keep repeating themselves. Square root of 3 over 2 and 1 over 2 in different forms, positive and negative, and in different positions, one being x and one being y. Write the measure in radians. Express your answer in terms of pi. In order to go from degrees to radians, you need to multiply by pi over 180. If you want to go from radians to degrees, you're going to do the inverse, 180 over pi. So all we're doing is multiplying this times pi over 180. What that does is it puts a pi answer, or it puts a pi unit in there for you. If you want radians, you need a pi unit. So the first thing a lot of y'all like to do is get rid of the zeros. Now you're dealing with the number negative 23 and 18. Negative 23 is a prime number, so this is going to be simplified as negative 23 pi over 18. And that is the radians that go along with negative 230 degrees. The same thing with 45. We're multiplying it by the same pi over 180. So over 1 times pi over 180 degrees. So what number goes into both of these? Well, 5 definitely does, but even bigger than 5, 9 does. So if we cancel this one out, 9 is going to go into 45. We may even reduce it again. 9 goes into 45 5 times, and it goes into 180 20 times. So look, we can reduce this again. The number 5 goes into itself once and into 20 4 times. So you're left with something as simple as pi over 4. '24 asks you to write these measures in degrees. So to go from degrees to radians, you multiply by pi over 180. To go from radians to degrees, you multiply by 180 over pi. So take 4 pi over 5 and multiply by 180 over pi. The way you can remember that is because remember, the same thing at the top and the bottom gets to cancel it out. You need to cancel out pi to make degrees. You can also cancel out the fact that 5 goes into itself once and it goes into 180. It goes into it 36 times. So you have 4 times 36. 6 times 4 is 24. 4 times 3 is 12, plus 2 is 144 degrees. Negative 11 pi over 6, you're going to do the same thing. Negative 11 pi over 6, you multiply it by the same 180 over pi. Because remember, you have to cancel out pi over pi. That's how you know you got it right. The number 6 goes into itself and 180 goes into itself once. And it goes into 180 30 times. So you're multiplying 11 times 30, or negative 11 times 30. So negative 330 degrees. Number 27 says to find the exact value of cosine 3 pi over 4 radians and sine 3 pi over 4 radians. So what you want to do is on your unit circle, go find 3 pi over 4. So look on the inside part. If you look at it, it's talking about this measurement right here. In standard form, it's talking about this one right here. Okay, 3 pi over 4, that's the one that its point is negative square root of 2 over 2, square root of 2 over 2. So we're going to use those values, the exact values of cosine. Remember, cosine, if you're talking about the reference angle here, this one, is cosine is adjacent over hypotenuse. This will be the opposite one. So your x value, the adjacent one here, is negative square root of 2 over 2. The opposite, the y value, is square root of 2 over 2. So your cosine of this one, cosine of 3 pi over 4, equals the Adjacent over the hypotenuse. Here's your adjacent. Negative square root of 2 over 2. Your sine is the opposite. Sine is of 3 pi over 4. You're still using the same one. Equals the opposite one, the square root of 2 over 2. Notice how similar those answers are. One's positive and the other negative. We're going to do the same thing for number 28. It says find the exact value of sine negative 4 pi over 3. Again, go on your unit circle and find 4 pi over 3. Now the negative is going to come into play here because this angle, when you open it up, since it's negative, opens up like this. And it gets to this point right here. You can see that this one is 4 pi over 3. 4 pi over 3. But we're not interested in that one. This one is 4 pi over 3, but it's 4 pi over 3 when it opens up the other direction. Remember, all of your units are when it actually opens up this way. We're not talking about it opening up that way. This is very important that it opens up negatively. So what you're going to do is you're going to find the same position going negatively. So you're looking for the one in this position to where when you open up this way, you get to that position. That one, as you look at it, you can see is the same wherever 2 pi over 3 is. So that's the one you want to use. That point is what's important. That point right there. That point, and I'm going to draw an arrow to it just to have enough room, is negative 1/2 the square root of 3 over 2. Again, if you're looking for the sine value of that, now it makes it a little bit easier if you get rid of everything else. So now if you're just looking at it from a reference position, so you're just looking at that angle now, that one. You're just looking at this one. Remember, you won't use that when you use the reference angle, which comes from the x-axis, this one here. So this will be your reference angle here. So the triangle that looks just like this is the one you're using. Remember, this is your 90. This is your reference in regards to negative 4 pi over 3. This is your x-axis. Your x is this one, negative 1 over 2. This is your y-axis. This is your y. That equals the square root of 3 over 2. So you're looking for the sine of that. Remember, sine is the SO. Sine equals opposite over hypotenuse. Opposite in reference to this one is the square root of 3 over 2. Remember, it's over the hypotenuse, and your hypotenuse is 1 when you're talking about a unit circle. So it would be over 1. So the sine of negative 4 pi over 3 is equal to the square root of 3 over 2. And that's the exact value. No rounding or anything involved.